Hello, good evening. My name is Sheikh Mehboob Jilani Basha. My cohort is WD2410A. And today I am going to explain 5 problems in this video. First of all, I will start with that is power of 2. Means in this we are checking the n greater than 0 and bitwise operator n and of n minus 1 equal to 0 behaves an instant. Mainly we have to focus into two areas. One is n greater than 0 and another one is n and of n minus 1 equal to 0. Here, what is happening in this problem? We are using logical or operator instead of logical, and this logical or it will check either this or this. If the condition is true, suppose if my n number greater than my n is 2 or 3. Suppose I will take 2 and n2 is greater than 0. So it will check only this condition and eliminate this part, and it will return true, and it will whatever the condition is true or false, it will show in the response. So we have to this logic we have to replace with the logical and logical and here now it will convert into binary code and it will return the properly. And the we have to use logical and operator. Yeah. Yeah, in this second problem, min add to make valid. In this problem, analyze what the variables close and open parentheses were intended to represent various how they were actually begin manipulated. In this, should track the number unmatched parenthesis open encounter so far, which need to corresponding closing parenthesis. In close in close unmatched closing parenthesis which need to corresponding to the opening parenthesis. And trace here execution. I run a simple test s equal to uh, pa- opening parenthesis, closing parenthesis, and closing parenthesis through the code. See if the state changes matches the logic expectations. Here I get the abstraction encounter. The primary abstractor was inverted logic inside else block. Here, inside else block, from here to here, yeah, else block, the code was performed a exact opposite action required when a closing parenthesis was encountered. Matching error is in this when open is positive mean have a closing. Wait, the code finds a closing parenthesis and increase else increment close. This is incorrect. Finding a match should reduce the count of unmatched open parenthesis. Here, match error in this is match error. When a open is o mean no opening parenthesis is waiting, the code finds the closing parenthesis and decrease the open, makes it -1. This incorrect and execution this incorrect and execution counter to track. We need to add opening parenthesis later. To fix this, we have to use greater than. We are checking greater than to 0. Then we have to use open parenthesis minus minus, and here we have to check closing parenthesis plus plus. Yeah, in this, here the corrected logic, the open variable tracks needed right parenthesis and closed tracks needed left parenthesis. Now I am explaining cell point. Here we have to analyze here the problem required us to access the last one or two valid scores, to compute new ones, or to remove the last one strongly. The last in first out behavior strongly suggests using stack pattern rather than modifying the input array. The loop condition here. The loop condition is I less than equal to operation length. We have to ensure adherence to zero base index ruling common in JavaScript. It the index value start from zero in array. Uh, I encounter the obstacle in this code. Tab none. If the code running is and the array zero, the array of index start from zero index. If an array has length 5, the valid index is 0 to 4. This loop goes until 5. Consequences, this length returns the undefined in some summation loop. Adding undefined to the number returns in the nan means not a number, crashing the calculations. In this place, we use the slice here, and modify the operation of I directly, mixing unprocessed instruction and with processed scores numbered in same array in dangerous, using slice to resize the array while integrating through iterating through the forces complex index manipulation. So our strategy is in this problem is we have to use separate stack instead of overwriting the operations array. We create a new array called record or stack to store any valid numerical scores. Simplify logic. If we see number to push to record, we see pop up the last item record. If we see D or plus, look at the end of the record using record dot length minus 1, calculate the new value and push it to it. Fix the loop, iterate using for loop of standard I less than operations dot length loop. Problem is happiness. First of all, we have to understand the problem statement. Function, this is happy function determines if a given integer is uh, 1 less than equal to n less than equal to 2 to the power of 31 minus 1 is a happy number. A happy number repeatedly replaces itself with sum of square of its digits until it reaches one of entering a cycle excluding one. Approach to solve this problem is identify the cycle efficiency without extra space. Suppose we have to take two pointers, one is slow and another one is fast. Slow pointer advise uh, one step, while a fast pointer advise two step per iteration. They meet a cycle if unhappy reaches one. Here in this problem we can solve with three based on tracking, O of n space with O of 1 and O of log n times as a digit sum. And we have to here we take helping correctly compute sum of squares handling edge cases like n equal to 1, n equal to 1. Do while loop ensure at least one iteration detect them detect cycle when pointer collides post meeting, checks verifies if endpoint is 1 or not. To correctness proven for this problem known unhappy cycles is 4, 16, 37, 58, etc. To improvise this problem, this code, we have to add if n equal to 1 return to early minor optimization. Set based alternative for clarity cons in new set while n n not equal to 1 and logical n not seen as n. Yeah, I will explain. Now I will explain palindrome problem. Here core idea for this number is a number is a palindrome if reverse it digits give the exact same number. For example, 12321, the output should be equal to 12321. And negative numbers are usually treated or not palindrome because the minus sign or appear on the left. So 1 to 1 minus 1 to 1 reverse would look like 1 to 1 minus, so which is not correct. Ways to check the palindrome number: there are three common approach that match the answer. First of all, we have to check for string approach. Convert the number to a string, then use two pointer or one of the start, one at the end. Move them toward the center and appear characters. If any pair differs, it is not palindrome. Second one is full reverse approach. Work with the integer, build a reverse version digit by digit using modulo to take the last digit and integer division to drop digits, then compare with a reverse and original. And now half reverse optimization. For very large number, some solution reverse only half of the digits and compare the two halves, which avoid the potential overflow in language with strictly a integer limit. And this is how palindrome reverse in the uh, integer and compare the idea. It pursues the original value back and then rebuild a reverse dump num by repeating tracking the last digits with percentage 10 and pushing it into the reverse number with dump into 10 plus rem. After the loop, if dump number equal to back n, it return true, meaning the number read the backward as forward. Yeah.